This is my lesson for trigonometry for Friday, January 8th. And this would be for odd block classes. So if you take a look here, the handout that you received yesterday is about learning how to draw angles in standard position. And so, at least that's the first part. If you look in the upper left corner, theta is an angle of negative pi over 4. So what you always want to do is start by drawing the initial side on the positive x-axis. That's what I've drawn right here. That's the initial side. Then you want to figure out which direction you have to do your rotation. If the angle is negative, we want to rotate clockwise around the unit circle, whereas if it is positive, we rotate counterclockwise. So since our angle is negative pi over 4, we rotate clockwise, and you can see this indicated by the red arrow here. That's indicating the direction you're rotating from the initial side to the terminal side. Of course, the terminal side is for the angle, and if we go negative pi over 4, our terminal side is right here, going through the middle slash mark because pi over 4 is a multiple of 45 degrees, which is half a quadrant. So our terminal side lands in quadrant 4. We should know each of our quadrants. The upper right is 1, the upper left 2, the lower left 3, the lower right 4. When we talk about angles in class, we will refer to the quadrant which the terminal side lands. So let's try. 3 pi over 4. We want to count by multiples of pi over 4. We're going counterclockwise because the angle is positive. So I already have my initial side drawn. This would be the first multiple of pi over 4, second, third. So I want to draw my terminal side through that slash mark. And then my arc indicating the rotation would go like that. That means that our terminal side ended up in quadrant 2. Let's try our next one. Now we see on the middle row on the left, negative 7 pi over 4. So I've drawn my initial side at the positive x-axis. Since my angle is negative, I'm rotating clockwise, and I want to count 7 multiples of pi over 4. So this would be 1, 2, 3, 4, 5, 6, 7. So when I draw that angle, I'm going to draw through that middle slash mark, and the rotation, even more importantly here, is going around like that in a clockwise fashion. And the quadrant we land in for our terminal side is quadrant 1. Let's draw our third angle. That is 13 pi over 4. Now, when you have a denominator of 4, so that you understand what 1 revolution is, which is really 2 pi. Actually, let me erase this and move over a little. Let me do this over here. So if we want a denominator of 4, an easy trick is you double that number in the denominator, which is 8. And I'm going to suggest 8 pi over 4 will be equivalent to 2 pi, or 1 revolution. So I know 13 pi over 4 is more than 1 revolution because it's more than 8 pi over 4. It's actually 5 pi over 4 more than 1 revolution. We are going counterclockwise because it's positive. Some people like to count. They go, 1, 2, 3, 4, 5, 6, 7, 8. That's 8 pi over 4. Then 9, 10, 11, 12, 13, and they draw through like that. And you could. I prefer to think, okay, I've gone 8 pi over 4 for one revolution, and then I count 5 more multiples of pi over 4. And that would mean, that would mean I do something like this. I already went 8 pi over 4, 9, 10, 11, 12, 13, or you could have counted 1 to 5. Either way is fine. We were rotating counterclockwise, so a revolution plus. So we need to make sure that we're showing that complete rotation. And of course, our terminal side here landed in quadrant 3. And you don't have to label that quadrant every time, but I've now shown you a terminal side landing in each of the 4 quadrants. So let's move our diagrams up. Now we've got negative pi, 7 pi over 6. So now we're counting by multiples of pi over 6. Remember, there are 3 multiples of pi over 6, or 30 degrees, in each quadrant. And I want to go clockwise because my angle's negative. So from my initial side, that would be 1, 2, 3, 4, 5, 6 pi over 6, 7 pi over 6. So I would draw through like that. And I would draw my angle and my arc. My arc is going to be drawn clockwise here from initial to terminal side like that. Let's try 5 pi over 3. Now, multiples of 5 pi over 3 are a little harder to count because it's really 5 multiples of 60. Now, 60 degrees does not divide evenly into a quadrant, but it does divide evenly into a half circle or a semicircle. There are 3 multiples of 60 in a semicircle, or half the unit circle. So like counting by multiples of pi over 3, this would be going counterclockwise. 1 multiple of pi over 3, or 60 degrees. Then this would be 60, 30 and 30. And then this would be the third, 4, 5. So my next multiple of pi over 3, I am going to go through this way, like that, and my direction of rotation is like that. Some people do like to convert 5 pi over 3 to 10 pi over 6 by multiplying the numerator and denominator by 2. If you do that, then you can count 1 multiple of pi over 6, 2 multiples of pi over 6, 3, 4, 5, 6, 7, 8, 9, 10. So if that's easier to count multiples of pi over 6, that would be a different way of doing that. All right, so now we're going to move down and do a few more. I'm going to try to go a little more quickly. 5 pi over 6, 1, 2, 3, 4, 5 pi over 6. And then we're going to do our rotation, which is counterclockwise. Negative 2 pi over 3, we're going clockwise this time. So this, if you want to convert to pi over 6, that would be negative 4 pi over 6. You are multiplying both numerator and denominator by 2. So you could count 1, 2, 3, 4. Or if you prefer counting 1 pi over 3, 2 pi over 3, that works as well. Your choice. But whichever way you do it, the terminal side goes here. The rotation is clockwise because our angle is negative. 8 pi over 3. I'll try counting counterclockwise. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4, 5, 6, 7, 8. So I did more than one revolution. Remember, one revolution with a denominator of 3 would be 6 pi over 3. That's what equals one revolution. But we're 2 pi over 3 beyond that. And of course, our angle's like that. Negative pi. That's easy. We're just going clockwise pi radians, and we would be going this way. And finally, 5 pi over 2. This is counting by multiples of pi over 2, or 90. So this would be my first multiple of pi over 2, second, third, fourth, fifth. So that angle would be right there. And we would have gone 1 revolution plus. I hope that makes sense to draw an angle in standard position. Now, you're going to have to turn your iPad. So I'm going to go through these handouts slowly here. But coterminal angles are angles that have the same initial and terminal side. So anytime you add, let's go with purple. Anytime you add a multiple of 360 to an angle or subtract a multiple of 360, because k is just any integer that's either positive or negative, you are going to find angles that are coterminal. Coterminal angles have the same initial and terminal side. So when I look here at an angle of 60 degrees that they have drawn, when I add 360 up here, I get 420. And a 420 degree angle would be a full revolution plus 60 degrees more. So its initial side and terminal side are also the same as the 60 degree angle. On the other hand, if I add a negative 360, I'm going to go counterclockwise, or not, I'm going to go clockwise, and I'm going to end up at the same terminal side. So I have an angle, I actually have 3 angles that all share the same initial and terminal side. And those are 60 degrees, 420 degrees, and negative 300 degrees. And it's just easy because all you do is add and subtract multiples of 360. So on the right, same thing. I have a 240 degree angle drawn. If I subtract 360, that's negative 120. So it shares the same initial and terminal side. On the other hand, if I want to add 360 to 240, I can find a 600 degree angle. It's not drawn, but you would go a full revolution plus 240 more, and you would have the same initial and terminal side. So you're going to add and subtract multiples of 360 to find coterminal angles. So in this next slide, it says find a positive angle less than 360. So within one revolution that is coterminal with the given angle. So in A, they gave you 390. Since it's more than one revolution, we subtract 360, and 30 would be coterminal. 405, same thing. It's more than one revolution, so we subtract 360 to get 45. Negative 135 is actually negative, so we have to add 360, and we get 225 degrees. What happens if our angles are in radians? Well, the first one, same directions, find a positive angle less than 2 pi that is coterminal with each of the following. So when we have 5 pi over 2, we have to focus on the fact that if the denominator's 2, then 4 pi over 2 is 1 revolution, or 2 pi. And so 5 pi over 2 is, of course, more than 4 pi over 2, so we subtract 2 pi, or 4 pi over 2, and our answer is pi over 2. When we have a denominator of 4, 8 pi over 4 is 1 revolution, or 2 pi. And since 11 pi over 4 is more than 8 pi over 4, we subtract 2 pi, or 8 pi over 4, and our answer is 3 pi over 4. Negative pi over 6, when that denominator is 6, 1 revolution is 12 pi over 6. So since my original angle is negative, I need to add 2 pi, or 12 pi over 6, and I get 11 pi over 6. This third slide says find a positive angle less than 2 pi, or 360 degrees, that is coterminal with the given angle. So I'm going to have to either add or subtract 360 or 2 pi. If I'm in degrees, I'm using 360. If I'm in radians, I use 2 pi. So they actually want you to figure out how many revolutions you're dealing with, more or less than. But to me, it's actually a lot simpler to just look at your angle. In the case of 765, it's obviously more than 360. So up here, what I like to do is subtract 360. If your answer is still more than 360, you've got to subtract 360 again, which we did, and now we get our final answer, which is 45 degrees. If you want to figure out that 2 multiples of 360 is 720, and then subtract that from 765, you can to get the same answer. But to me, it's just simpler to subtract 360. If it's still too large, subtract again, and just keep repeating till your answer is within 1 revolution. How about when it's in radians? Well, 22 pi over 6, we obviously know with a denominator of 6, 12 pi over 6 is 1 revolution, and 22 pi over 6 is obviously more, so we subtract it right here. That gives me 10 pi over 6, which is less than 1 revolution, since the numerator is 10 instead of 12. So all I did was reduce it to 5 pi over 3. How about negative 19 pi over 6? Denominator of 6, so 12 pi over 6 is a revolution, and I have to add it here because my original angle is negative. When I add, I get negative 7 pi over 6, so I get to add 12 pi over 6 again, and now I finally get a positive answer, which is between 0 and 2 pi. So that's coterminal angles when you have to add or subtract multiples of 360 degrees or 2 pi. Last slide, last 2 slides, I guess. The length of a circular arc in a circle. You'll remember earlier at the top here that an angle in radian measure is found by taking the arc length S and dividing by the radius R. And I'm suggesting if you multiply both sides of that relationship by R, you come up with this new equation which says S, the arc length, which you can see here, is equal to the length of the radius times the measure of the angle in radians. That's the key. because they usually don't give you the answer in radians for the angle. So I'm going to show you that here. There's two examples. The first example says you have a circle that has a radius of 7 inches and an angle measure of 120 degrees. The common mistake is just to plug in for the radius and the angle with what they give you, and 7 times 120 is 840, and that's not the measure of the arc length. And that's because the angle is not in radians. So what we do is right here, we convert it to radians. We take 120 degrees times the conversion factor, pi over 180. The degree unit cancels, you get 120 pi over 180, and that reduces to 2 pi over 3. That's what you want to plug in here for the angle theta. It is now in radians. Of course, 7 times 2 pi over 3 is 14 pi over 3, which we can use a calculator to approximate, and 14 pi over 3 is about 14.66 inches. The next example, similar. We've got 5 inches, 150 degrees. We convert 150 degrees to 5 pi over 6, and then we plug in with the radius and the angle in radians. We get 25 pi over 6, or about 13.09 inches. All right, I know that was a mouthful, but you need to do 4.1b and 4.1c in My Math Lab, which you can find all this information also on Canvas. Thank you.